Hello everyone, this is Varsha from 4th SEM CSE AI Department, SVCE College of Engineering. In this session, we will discuss about probability, mass and density functions, mathematical expectation, mean and variance of binomial. Our agenda. In this session, we will see about probability mass function, probability density function, mathematical expectation, what is binomial distribution, mean and variance of binomial distribution, and their applications. Next, let us see probability mass function. What is probability mass function? A probability mass function is a function that describes the probability of a discrete random variable. It maps the events to their probabilities. Let us see the examples of probability mass function. Die rolls, coin flips, and sampling from a deck of cards are the daily life examples of discrete events for which a probability mass function can be used to describe the probabilities. Next, let us see how to interpret the probability mass function. Probability mass function can be visualized as a bar charts where the height of the bar represents the probability of each event. Here, let us see those bars. Those represent the probability of each and every event. Next, let us see the definition. Probability mass function assigns probabilities to finite set of outcomes in discrete random variables such as coin flips and dice roll. Let us see the formula. Probability mass function of F is equals to P of capital X is equal to K. Next, let us go with the properties. Sum of probabilities assigned to all possible outcomes is always equal to 1. This condition must be satisfied. Next, let us go to the probability density function. What is probability density function? A probability density function is a function that describes the probability of continuous random variable. It maps the values of variables to their probabilities. Next, examples of probability density function. Normally distributed events like height, weight, and test scores are examples of continuous events for which a probability density function can be used to describe the probabilities. Next, how to interpret PDFs. PDFs can be visualized as line plots where the area under the curve represents the probability of event. In a graph, the area under the curve represents the probability of event. Next, let us go with the mathematical expectation. What is mathematical expectation? Mathematical expectation or expected value is a measure of central tendency of probability distribution. It is weighted average of values of random variables. Let us see how to calculate the mathematical expectation. For discrete distribution, you must add up the product of outcome and its probabilities. Whereas in continuous distribution, you must integrate the product of density and variable over the range of variables. Let us go with the real world applications. We can see expected value is used to calculate the fair price of insurance policies, casino games, and other situations where there is a risk of loss or gain. Next, let us go with binomial distributions. What is binomial distribution? A binomial distribution describes the number of successes in a fixed number of trials with a known probability of success. Next, let us go with some of the properties of binomial distribution. Fixed number of trials, that is, the binomial distribution is defined for a fixed number of trials n, which represent the number of independent Bernoulli trials performed. Next, let us go with the independent trials. Each trial is independent for the others, meaning the outcome of one trial does not influence the other outcome of another. Next, probability of success. In each trial, there are two possible outcomes, that is success or failure. The probability of success on each trial is denoted by P and the probability of failure is 1 minus P, also known. Probability mass function. The probability mass function of binomial distribution gives the probability of observing a specific number of success in n trial for the PMF is given by P of x is equals to k is equals to C of n comma k into P power k into P 1 minus P power n minus k. Next, let us see who invented binomial distribution. The binomial distribution was not only invented by a single individual, but rather developed through the work of multiple mathematicians over time. One of the earliest references to the binomial distribution can be traced back to Swiss mathematician Jacob Bernoulli in the 18th century. Jacob Bernoulli introduced the binomial distribution in his work Arcs Conjecturendi, published in 1970. Next, let us see mean and variance of binomial distribution. How to calculate mean? The mean of a binomial distribution is equal to product of number of trials and probability of success. It is denoted by mu. Mu is equals to n into p. Next, let us go with the variance. How to calculate variance? Variance is given by sigma square, that is equals to n into p into q, where n is number of trials, p is probability of success, and q is probability of failure. Next, let us go with the applications of binomial distribution, mean and variance. It is used in gambling, quality control, software testing. That is to analyze bets such as casino roulette, dice, and game of chance. Quality control. Binomial distribution, mean and variance are used to find acceptable level of quality. It is also used in software testing. Next, let us go with the binomial distribution applications. It is used in sampling and also in medical tests. Binomial distributions are used in survey sampling to calculate probability of selecting a certain number respond. And it is also used in a medical test to find the probability of false positive or false negative result in medical test based on sensitivity. Next, let us go with real-time examples using binomial distributions. Election predictions, flipping a coin, business forecasting, binomial distributions are used. Let us see with flipping coin. Probability of getting a head is 1 by 2. Next, in election prediction, that is based on number of undecided voters and margin of error of polls, results can be used to calculate the probability of candidate. Next, let us go with the limitations of binomial distribution. There are some limitations of binomial distribution, that is binary outcomes. The binomial distribution is designed to handle situation with only two possible outcomes. If the event has more than two, binomial distribution is not appropriate. Next, fixed number of trials. The binomial distribution assumes a fixed number of independent trials. Number of trials may not always be fixed. So, binomial distribution to apply, then it will become a challenging task. Next, independent trials. Binomial distribution assume that each trial is independent of others. In some cases, these assumptions may not hold true. If outcomes of one trial are influenced by another outcomes, then we cannot apply binomial distribution. Next, constant probability of success. The binomial distribution assumes a constant probability of success for each trial. In reality, the probability of success may vary from one trial to other trial due to the external factors. Next, discreteness. Binomial distribution is probability distribution with discrete random variables. It may not accurately model situations with a continuous or have a large number of possible values. Thank you.